Hello, everyone. Welcome back to another episode of Adventures in Machine Learning. I'm your host, Michael Burke, and today we are joined by Ben Wilson. Thank God he's back.
Hey there, everybody. It's good to be back.
And today we have a special guest, Ahmad Anis. He is currently a machine learning engineer. He studied computer science in undergrad and has worked as a deep learning and computer vision software engineer. And he's been doing some blogging, which is how we found out about him. And now he's currently working at Redbuffer as a machine learning engineer.
Hey folks, this is Charles Max Wood from Top End Devs. And lately I've been working on actually building out Top End Devs. If you're interested, you can go to topenddevs.com/podcast and you can actually hear a little bit more about my story, about why I'm doing what I'm doing with Top End Devs, why I changed it from devchat.tv to Top End Devs. But what I really want to get into is that I have decided that I'm going to build the platform that I always wished I had with devchat.tv, and I renamed it to Top End Devs because I want to give you the resources that are going to help you to build the career that you want, right? So whether you want to be an influencer in tech, whether you want to go and just max out your salary and then go live a lifestyle with your family, your friends, or just traveling the world or whatever, I want to give you the resources that are going to help you do that. We're going to have career and leadership resources in there, and we're going to be giving you content on a regular basis to help you level up and max out your career. So go check it out at topenddevs.com. If you sign up before my birthday, that's December 14th. If you sign up before my birthday, you can get 50% off the lifetime of your subscription. Once again, that's topenddevs.com.
So, Ahmad Mustafa, do you mind introducing yourself a little bit more and telling us potentially why you are famous?
Hi everyone, my name is Ahmad Anis, and I have recently completed my bachelor's in computer science from Pakistan, and I'm working as a junior machine learning engineer at Redbuffer. And I have written quite a lot of blogs, which are basically what I have learned over the time. And most of them were on KD Nuggets. Some of them were published on Towards Data Science, and some of them are on our company's publication of Redbuffer at Medium. So yeah, that's pretty much it about me.
Cool. And what do you do specifically at Redbuffer? What type of projects are you working on?
So Redbuffer is basically a services-based company, and most of my work, it was around computer vision, but I have other experiences as well. I have worked in creating dashboards as well in Python, and other work was around computer vision mostly.
What kind of computer vision specifically?
So I have joined Redbuffer around 5 months ago. So most of my work in computer vision was revolving around OCR. So I was working on a system which required a lot of OCR work, and we wanted it to be quite fast. So that was like most of my work was there.
Sounds cool. And for those of you who don't know, OCR is optical character recognition. So recognizing license plates, for instance, or for example, an address when you're sending a letter. If we want to automate that and see where the address or where the letter should be sent, we can use machine learning to figure out where it should go. So you mentioned latency requirements. What types of applications require low latency?
So that was a project, and the requirement was to make it in real time. So I cannot disclose a lot about the project itself, but what the main target was that we want to achieve something which can work really fast on low hardware requirement, and the main portion was OCR.
What type of hardware are we talking?
Figuring out mostly normal laptops, like not GPU specific. So like we do not want it to be like just run fast on NVIDIA laptops or NVIDIA desktop. So we wanted to work fast on every laptop. So essentially our goal was to optimize it for CPU, not for GPU.
That's super cool. Can you tell us anything about the application whatsoever? Only time I'll ask. I'm just curious.
I cannot disclose about the application itself, that what was the application, but I can definitely tell about my learning. I've learned quite a lot of things in that process, how to optimize the OCR, how to look for the things that can actually fasten your pipeline. So yeah, I can talk about that.
Yeah, that'd be great.
So there were quite a lot of things that were actually factors that actually plays an important role in a fast OCR. One of the important things which I think was missing in a lot of tutorials online, when I was referring to the online material, was how to use multiprocessing or multithreading in such a system. So, for example, I was using TetherX. TetherX does provide some multi-threading options that are built inside it. But that multi-threading option was not like, that does not produce very good results. And it was using multi-threading. And what we were focusing on was using multiple processes so that we can utilize all our CPU. So I definitely jumped into the multiprocessing portion and look for different techniques that I can use to speeden up my pipeline. So some of the things which I tried were like I tried slicing the image into different parts and pass them into different processes so that an image can be processed multiple times in same span of time in different processes. But one of the reasons that didn't work quite well was because even though we were reducing the time of OCR, which was on single image, but eventually it was increasing the number of calls of the OCR, which itself was quite an expensive thing. So slicing an image was not a great option. So what I eventually did was just that I created multiple processes, and for each process I was processing a different input to my OCR. Something which actually gave a lot of speed boost to our system.
So you're parallelizing on a single system. For the listeners out there, could you break down what we're talking about? Not everybody's going to be familiar with the difference between multiprocessing and multithreading, but could you get the 1,000-foot view and explain it to the audience? Like, hey, this is what we're talking about here.
So I can explain it on a high level that multi-threading, these are basically operating system concepts. And multi-threading is basically a concept which allows the process to run multiple threads inside it. And in multiprocessing, we can actually run multiple processes or multiple CPUs or multiple cores. So we are running in and multi-threading is mostly for IO-bound jobs. So, for example, if you have a job which requires some IO time, which has some waiting time, so you can use multi-threading and you can actually just bypass that IO time, which is in which system is waiting. In multiprocessing, you have multiple processes that are running in parallel and doing the same job, which essentially speeds up your pipeline or speed up your process by the time your number of processes you are running.
So in multiprocessing, we have memory isolation and thread isolation across those processes. Whereas in multi-threading, we have a common threading pool that tasks can be submitted via futures to different threads, and threads can be reused when a task completes. So when we're talking about IO-bound tasks in relation to ML, you bring up a great point with images. Images are big. They take a while to load up, and a lot of that is IO bound, but some of it, and then you go into the actual model execution itself, which is going to be, in your case, CPU bound. In the other, scenario that we were talking about before with NVIDIA chips, you're using GPUs, it'd be GPU bound. I was just processing through that. So when we're talking about the multi-threading concept, why does that not work so well for your use case? Like from a technical standpoint, what's going on in the CPU that's sort of breaking stuff?
So actually, when I completed the basic pipeline, I just profiled my code. So what I found out that the 96% of the time is spent inside the OCR, like when the OCR step is actually being performed. So my main focus was to optimize that 96% part and bring it down. And I was not focusing mainly on the rest 4% part, which was actually reading the video and stuff like that, other stuff which was happening. So I was focusing main on that 96% task, which was the CPU bound. So I was focusing on multiprocessing.
Yeah. So to translate what you just said to people, when you're talking about those long running CPU tasks, if you're using multi-threading, you're locking a thread for the execution duration of that. So you're not getting the benefit of task switching to additional threads because the task runs so long. You can actually exhaust your thread pool relatively easily with CPU bound tasks, and it can create resource contention on the CPU, which slows everything down, and it just becomes really inefficient. Whereas multiprocessing, which is designed for that CPU bound, you're locking resources and saying, hey, I'm going to do 4 of these things all at the same time, and each of them are going to get its own core, and it'll manage its own thread processing within that multiprocessing, sort of pseudo container, and it becomes more efficient. So if anybody listening wants to sort of process that, think about it for a moment. When you're talking about using these more advanced concepts rather than, just doing a list comprehension or a for loop within your code, and you want to get better performance, try to keep that in mind, that relationship. CPU bound tasks, multiprocessing is going to work better for you. IO bound tasks, multithreading is usually going to work better for you. And then anytime you're using this sort of stuff, don't forget to read the docs. The underlying versions of the language and the libraries that implement this. Most of this is language native information, probably talking about Python here. Those libraries change. Like Python 3.7 to 3.8 had a major change in multiprocessing and multithreading. There's a very large refactoring of the underlying code base for that, changed how it behaves, massive performance improvements. But you're only going to know that if you go and read the docs and get familiar with the APIs and the examples that are in there to know how to do this. Because these processes are a nightmare to troubleshoot if you don't know what you're doing.
Oh, yeah, definitely.
So Ahmad, you said that
is so hard. You get so strange error messages that actually you do not understand. If you are working just like copying pasting the code, and if it just does this and you get an error message and you have no idea where it leads you to, and you have no idea what is it saying.
So when you talked about before an OCR process fails, and how do you handle in multiprocessing land with an ML task like that? How do you handle a retry when we're talking about futures in Python? How did you figure that out and implement that in a way that you could not bottleneck the processing of your real-time system?
So yeah, definitely there was a limit. There was a limit that so I did not create a lot of processes. So the number of, I did prune some space for other tasks as well. And definitely there was a limit. So we have, when the frames are coming in real time. So I have to set a threshold that if my system is being slow, so a lot of frames can get stacked into memory, and that can actually just take all of your RAM, and your system will eventually crash. So multiprocessing module in the Python, it actually gives you the option that inside its data structures, which you are using, that we can specify its length so that it does not get overflow and eventually crashes your system.
So if we're going to do this at an extreme scale, like customers of the company that Michael and I work for, when we're talking about video processing with OCR, and you're taking in 10 terabytes of data an hour of video feed. Did you have any problems like that, like scale of that magnitude where you're like, hey, I can't handle this I'm not thinking on just a single CPU scale. I'm now thinking on multiple CPUs across multiple machines. Did you get into that world of complexity?
I know it was not that world of complexity, but yeah, when we were dealing with the 4K video, we ran into that problem. So the problem was that when we were working with 4K videos, the size of video is big, and the maximum use case was a 4K video in our case. So definitely by setting the threshold and doing some pre-processing before it to reduce the size of it a bit, it actually handled that. But yeah, our system was not on a very huge scale, and there was not terabytes of data in this case.
So it seems like you improved performance with the multi-threading, multiprocessing process. But what other methods did you employ to make it run on small hardware?
So another step when we were dealing with, and which worked, was that we do not actually need to perform the operation, OCR operation, or any other operation on every frame. So we do have a margin that we can skip some frames and we can get the desired result. So that actually plays an important role in having a boost in your pipeline. So if, for example, if there's an operation that is taking 96% of your whole pipeline time, and if you can skip it for, let's say, if we have a 30 FPS video and we can just perform it like 3 times in a second, every 10 frames, so we can actually get a quite good boost in the speed, and we can still retain a lot of information and we cannot miss anything. So that frame skipping part, that was actually quite helpful.
So one of the things that I've seen people do for this, in order to reduce the data density going to a deep learning model that's doing classification and multi-class classification, identification of, and defining bounding boxes, is doing dynamic differencing in a video feed, where instead of, the approach that you guys use is definitely completely legitimate. It's 100% what I would do initially. Like, hey, how often do frames really change? And what is the nature of this video? Is it something that's very fast moving? What is the rate of change of items within the frame? But for the things that are somewhat static and you might not have a change that occurs over a 30-second period, when you're talking about like surveillance video feeds and stuff, you're trying to do detection. In your pre-processing data coming in, you can maintain a buffer of the images coming in and saying, what is the general difference? Like how different are the pixels from my reference image that's sort of moving through time as a snapshot of a take effectively. And then as the new ones come in, do a quick check and say, what is the percentage difference here? And if it's outside of a threshold, then send that for classification. If not, discard. Were you thinking of something like that to further reduce that pressure, or was that completely out of scope?
So yeah, definitely we tried it, and which worked really well. So what we did was that we had to focus on a part of the screen. So that was our area of concern, and we have to see if that part if that part is still in the stream or not. So if that part is in the stream, we can actually skip the OCR process, and we use different techniques. So for example, we just in the first iteration we just localize that part. And we can use different techniques like template matching. So if our background is not changing very much, we can use template matching, and template matching works well on things which are static. We can also use some sort of tracker like CSRT or some other tracker, which are very fast. And as compared to OCR, they are really fast. So using these sort of techniques, they actually saved us a lot of time. So we did not have to OCR on every single frame. Instead, we just OCR'd on the frame in which the tracker was filled.
Yeah, I really like where you're going with this. And this really speaks to when we put aside the ML aspect of a lot of production deployments of things. A lot of people focus on the model and how cool it is. God, this image recognition model can do these things. And yeah, that's cool. But when you're talking about creating something that's going to be useful for humans to actually do something with, these are the issues that we're talking about right now. Like, how do we get this so this isn't going to cost a fortune to run? And how do we limit the amount of data that we have to feed into this to still get an acceptable result? Could it potentially be better if you analyze every frame? Maybe. But what is that gain compared to how much that's going to cost? And that's why I really wanted to talk about how did you do this, and how did you think about reducing that frame count? Because those creative aspects of almost pure engineering work that you have to do as an ML engineer, that's really where the magic happens in production deployment, is figuring that stuff out, coming up with a bunch of hypotheses to test, and then testing them all out, seeing which one works, what approaches solve this problem the best, what's the cheapest, and most importantly, what's the easiest to maintain. So yeah, thanks for explaining all that.
No worries.
And also, did you use any grayscaling?
Yeah, definitely. Grayscaling was actually a lot better. Like when we started, I was just fitting in RGB images, and when we grayscaled it, so it actually the results were no different. So the OCR was giving same results on RGB images as it was giving on grayscale images, and the speed was actually a lot better. And another thing which I noticed was when I was just doing experimentations with this thing, I actually added grayscale at the end of like the last step before the OCR. So when I just added that step in the start of my pipeline before the other processes, it actually gave more boost. So for example, what I want to explain is that if you use a process that will not change the results of your pipeline, but it will definitely improve the speed. So we have to take that step into the top before everything else happens, so that the time of every step reduces.
And then, the only time that you have to be creative about when you would do that conversion is if you're doing any sort of preprocessing that relies on color, where you're like, hey, I'm changing from RGB space to YCRCB or something in order to do some sort of color conversion or color matching or replacement. But if you're not doing that stuff, you don't need to do that stuff. The earlier you can reduce the dimensionality of that data structure that's coming in. We're talking about color and grayscale. In case any of the listeners don't understand what we're talking about with that, a particular pixel in color has a three-dimensional array that's in there, or the image is three-dimensional with respect to each pixel has an R, G, and B coordinate position. And the combinations of those three colors gives us the color based on hue and saturation of those values when they're rendered by a device. In grayscale, we're talking about a single value. Although there are some grayscale things that have two elements to it. But if you can reduce that dimensionality, that's so much less data that has to go through your model and your pipeline. So earlier you can do that, the better.
What are the two-dimensional grayscales?
There's one that has to do with like a lumen intensity as well as hue. I can't remember what the formatting is. It's been years, man, since I messed with that. But there was a particular file format that had that we were messing around with it at a previous job.
Super cool. Yeah, so that was one of my questions. And then another question is, this seems like it would lend well to transfer learning. Theoretically, you could have a large model up in your cloud or the user's cloud, and then you could do fine-tuning on a laptop. Have you guys thought about that at all?
So actually, in our portion, we were not training a model. So we were using pre-trained models. We were using pre-trained OCRs. We did not have to do any sort of our own training. So, but one of the things that I would like to mention was when we were using the model. So every model has a main. So when you are using pre-trained models or any model that has some sort of weights, there are weights that are actual weights and there are quantized versions of that weight. So the idea of quantized version is that to actually reduce the data type in simple terms of your weights. So for example, if your weights are in float 64 or float 32, you can reduce them to like int 8 or a very small data type. So it actually gives us a little bit of accuracy reduction, but that accuracy reduction comes in cost of good speed. So we were also using quantized models. So that was a good speed of factoring.
Yeah, when you're talking about the CPU computations that are involved in 64-bit integer operations versus int8, the memory and what the CPU is actually doing, the number of transistors involved in that thread process that's being executed, much lower. So you don't have to use L0 cache that much when it's executing that. And that adds up when you talk about deep learning. There's a lot of calculations that are happening throughout that model structure, pre-trained or not. You can doing it yourself and building a very simple, wide, shallow network. That's a really good point. And I think it's something that not too many people focus on, but they should. When you're talking about releasing something like, hey, let's figure out how good this needs to be. Let's get it to that. And then how can we save on costs by making things faster and cheaper and run on cheaper hardware? Excellent point.
Hi, this is Charles Max Wood from Top End Devs, and lately I've been coaching some people on starting some podcasts and in some cases just taking their career to the next level. Whether you're beginner going to intermediate going to advanced, whether you're trying to get noticed in the community or go freelance, I've been helping these folks figure out how to get in front of people, how to build relationships, and how to build their careers and max out. and just go to the next level. So if you're interested in talking to me and having me help you go to the next level, go to topenddevs.com/coaching. I will give you a 1-hour free session where we can figure out what you're trying to do, where you're trying to go, and figure out what the next steps are. And then from there, we can figure out how to get you to the place you want to go. So once again, that's topenddevs.com/coaching.
I'm just curious, what types of algorithms did you end up using?
Sorry, can you repeat that?
Yeah, what kind of algorithms did you end up using? You mentioned Tesseract, but what else, if any? Well, that'll be an easy transition to get back into.
Tesseract OCR.
Yeah, I looked it up last night too. HP developed in the 80s. Basically, they incrementally create bounding structure on black-white images.
Hi, can you hear me?
Yeah.
We actually just shifted our house, so the internet is quite buggy right now.
Got it. No worries at all. But this is the easiest transition so far. So the question was basically, what algorithms have you used? So if you could just start anywhere.
All right. So the major machine learning algorithm was only the Tesseract. That OCR engine was Tesseract which we were using. There was not actually much more machine learning portion involved in it. But yeah, we use different algorithms such as we use in the frame differentiation techniques, we use template matching, or we use tracker with CSRT tracker. And yeah, I guess there are some of the algorithms that are worth mentioning, which are famous. The rest of the portion was mostly software engineering process and the logic and operations that were being performed on the data.
Got it. And so sort of taking a step back, do you mind explaining a little bit about what Tesseract does and how?
All right. So Tesseract is basically one of the most famous OCR engines that is out there. And it is, I believe, backed by Google. And it is developed in C language. So it is quite fast. And they have like a lot of pre-trained models available. So if you have a general task related to OCR, so you do not need to do any sort of training. You just need to pass it to Tesseract with appropriate preprocessing, and yeah, it will give you all the text from it. So it is just deep learning. Tesseract version 3 was mostly classical computer vision and machine learning, but up to Tesseract version 4 and 5, they are using deep learning models such as LSTM and RNN. But one of the things which I found, which I did not like about Tesseract actually, was that it is all coded in C language. But if, for example, someone has a GPU, NVIDIA GPU. So you cannot actually speed up your computations with Tesseract. So you would have to shift to another OCR engine. So if you want to use GPU, a better choice would be using maybe Keras OCR or Easy OCR or Paddle OCR. So these OCRs can utilize your GPU as well. So setting up your GPU with NVIDIA GPU with Tesseract, that is I can say one of the hardest things you will ever do.
Well, you'd have to compile it and you'd have to get it to communicate with the GPU, right? Because it's not compiled for that. Yeah. That would be rough. I mean, any software package that's been around as long as Tesseract has, where it's been compounded upon over, when we're talking about something that's been worked on for over 30 years. HP Labs was the originator of that with the old school machine vision back in the day. And very widely used around the world. Yeah, it's hard to take that old code, and some of that stuff has probably been written in libraries that those languages are, for all intents and purposes, to a modern computer science field, seem like dead languages. Or you look at the underlying C code and you're like, wait a minute, last time this was edited was 1986? Really? And it still runs? Wow. So yeah, you'll see that with the really foundational things like that. Yeah, it's interesting to me how they ported a lot of that functionality over into version 4 and version 5. Google said, hey, let's run this on TensorFlow and we get Keras support here to sort of modernize that. Did you end up trying version 3 versus version 4 and see how the classic performed versus the deep learning implementation?
I actually tried version 4 versus version 5. So the version 4, I was using quantized model of version 4, and the version 5 model which I was using was...
Wow, this stuff is so cool. I was reading about it last night.
Yeah, when we were doing at my last job, we were doing image recognition. We did it with OpenCV manually, and that's how we had to learn all of the underlying, how do these libraries actually outline a shape in an image, and how do they determine what that is? And we didn't have it for our use case, so we had to build it all ourselves, and extend those libraries. Wow, this is tough stuff. It's cool.
Yeah. So welcome back, Ahmad.
So I did not try version 3 versus version 4, but what I tried was version 4 versus version 5. I was using quantized model of version 4, and the version 5 was non-quantized. And to my surprise, the version 5 model was actually giving almost same speed. It was a little bit slower than version 4 quantized model. So they have brought a lot of optimization in TensorFlow version. Mm-hmm. So when I just started, I installed Tesseract on my Ubuntu, and the default Tesseract which came with Ubuntu 18.04, I guess I was using, that was version 4. So I was not really aware that time about the version differencing of Tesseract at that time. So when I later on tested it, so I found it quite interesting that version 4 quantized models are a little bit faster than version 5 non-quantized models.
It brings up a very important point when we're doing evaluations for solutions in ML is test stuff out, particularly if you're an ML engineer. I mean, data scientists are always testing stuff out, right? I'm going to try this model. No, I'm going to try this other model, or I'm going to try this framework. But even from an ML engineering perspective, when you're getting a solution, which is the project we're talking about right now, you're effectively getting somebody else's air quote data science code in the form of a packaged model that somebody else already built. And you're having to figure out what's the best solution for solving this problem. You're testing stuff out. So people out there, listeners out there, that if you're in ML engineering and you're working with the data science team, they punt some code over to the wall and say, we need this in production. You can do exactly what Ahmad is talking about. We're going to test different things out. What different versions are there of this? Can we use a different operating system? Can we use different hardware? How can we solve this in the best way possible and do validation checks on our ideas? And so long as it meets the needs, not of the data science team, but of the business, then it's a good solution.
Yeah, that's good point. So as long as it meets the business need, it is a great solution.
So I wanted to also transition a bit into sort of more high-level concepts about teaching yourself machine learning. Ahmad, I know you're more sort of junior in your career, but you are very prolific in the blogging space, and have written some really, really great posts, seen a lot of success on KD Nuggets. So I was wondering, I have a couple quick hitters that I would like to ask both you and Ben as practitioners of teaching yourself ML. First question is, do you think certification programs are worth it? So you could take a Udemy course and get that certificate, or should you just read a blog and generally know what's going on?
I think they definitely helps. So having a certificate, it does help a bit. It might not be very worth it or very much, having a lot of importance. But yeah, it definitely helps. And it looks, especially when I'm as a junior engineer. So when I landed my first internship, my interview did not go very well. So what my ex-CEO, he told me that even though your interview is not very well, I can see that you are putting a lot of efforts in doing courses and having certificate. So I can see that you do have that motivation inside. So yeah, it definitely helped me in this case, having those certificates even though he did not check those certificates, but just because I had listed those on my CV and I had actually done those, he actually was inspired by it. So yeah, it helped me.
My take on it is going to be a little different, simply because I've been doing this a while. It's been a long time since I've been an entry-level person, but what I've seen over the years is when somebody's trying to learn something, there's two key factors that I think about. One is, what is their motivation? And with respect to motivation, are they going to be somebody who's going to self-teach themselves and can just find information where they need it, wherever they go, and they can develop their own learning plan of hey, here's what I need to do. Usually you need a mentor to do that with you if you want it to be efficient. But if you're completely on your own, and you don't know where to get started, you don't know even what to search for, or what to work on, or what foundation do you need? Those courses that provide those certificates are incredibly helpful because it's structured. It leads you down a learning path. Is it going to make you a professional data scientist or ML engineer after doing one of those courses? No, it is not. It's going to allow you to understand the breadth and scope of what you don't know. Because when you're getting started, you don't know what you don't know. You don't know where to go next. It's the same thing as in university. When you don't walk out of any university program knowing how to be a professional in your field. Nobody does. Internships help, but you're not going to go and do that stuff and then be immediately qualified to be somebody who's a foundational technical member of their company. You're going to be go from an intern and graduate, and you're like this new hire who has to learn a bunch of stuff. And the structure that you get from those learning courses, it's the same as in college. It's a structured program which is teaching you foundational elements, but at the same time, it's teaching you how to go and learn yourself. When you identify the gaps, or where you have a gap, and now that you need this skill, okay, where do I go to find out how to learn this, and how do I get good at this? So I think that structure is really good, and I'm always a big proponent of people doing those courses for that reason. And then the second element that's important for learning, whether it's be through reading a bunch of blog posts or doing a number of different certificate programs, is can you reduce the scope? And what I mean by that, we were talking about this yesterday, Michael, when we were talking about guitar learning. That I just started picking up learning guitar again after almost 20 years. And the guy that I'm learning from was talking about only learn what's absolutely essential when you're at that point. You don't pick up a guitar, learn your basic chords, and then be like, okay, I'm going to memorize all my scales, all my chords. I'm going to learn all the C-add-9 augmented chord and diminished minor chords for everything. And then I'm going to learn my jazz chords, and then I'm going to learn the blues chords. You don't do that because it's your brain just can't handle that amount of information. You can't be like, oh, I'm going to memorize all possible 347,000 chords on a guitar. It's useless. It's the same thing with ML or any technical thing that you're doing in your career. If you go out there just trying to learn information at random, you're not going to retain anything. You're not going to really know it. But if you have the foundation of like, okay, I have the tool set that I need to do this basic job that prepares me to understand when I encounter something I've never seen before and I'm really stuck and I have to learn this, I know how to go about learning that. And then I'm going to learn that thing because I need to learn that. And that's what I really see. Like, that's what blogs are really great for. You can go and find them and be like, oh, this explains this concept that I need because I'm working on a project that is doing this. That's my 2 cents.
Yeah, I completely agree. I think if you understand the fundamentals, you can learn anything. And especially in the internet age, there's just too much to know. Like, you could spend a lifetime working on OCR and still not scratch. Well, you probably scratch the surface, but you wouldn't potentially be the leading expert. Question for both of you, though, is, so we have this giant field of ML, right? And there are theoretically underlying principles and commonalities between different concepts. So, for example, if you learn how a decision tree works, you can probably learn random forests and other tree-based models. If you learn the basics of a neural network, you can learn RNNs and all these other crazy things. How do you identify what are the first principles of machine learning? I think that's one of the more interesting challenges that I've run into, because if you know what to learn and know where to, then you can just go to the internet and learn those things. But knowing what to learn and knowing what is a first principle versus a technique on top of a first principle, that's really hard to identify. So do you guys have advice on how to think about what ML first principles are?
I'll let you go first, man.
So what happened in my case was I had always when I started my CS journey, it was always in my head that I want to learn machine learning. And so I came across the podcast. I don't exactly remember the name of that podcast right now, but yeah, I think that person has also appeared in the Adventures in Machine Learning podcast once in a while, but that podcast series is different. So what he talks about that in that podcast was actually he just goes on at first he just explained the overall ecosystem of the AI and machine learning community and what things are present, and then he goes on explaining all the different basic algorithms. So that actually really helped me a lot in developing a path for myself. So he just explained all the concepts in easy words, and he would then recommend a lot of good resources for that. So, for example, he emphasized a lot on Andrew Ng's machine learning course for beginners, and that course was actually really good for someone who has not who do not have a lot of theoretical knowledge in machine learning and wants to dive in. I think he explains it in the easiest way. And definitely there are some other things in which he recommended along the way. So I created a path for myself with the help of that podcast and with the help of watching some YouTube tutorials. Before starting learning, I created a path for myself. So I know that I have to cover a good amount of Python. I have to cover basic amount of mathematics. I have to cover basic machine learning, supervised learning, unsupervised learning. These are the resources which I'm going to take, and these are that for quite some time. And yeah, I think that this thing really helped me listening to the professionals, what they say on creating a path for himself and having a complete path. I think it motivates you, and it gives you a structured knowledge, just like Ben talked earlier, that if you go on learning unstructured way, you might listen a lot of things, but you won't retain any of it.
So if I were to sort of summarize your point, it would be find a predefined structure, either through a lesson plan or a podcast or a bunch of YouTube videos that will outline those fundamentals. And then you can go about learning deeper wherever you want to, but make sure you rely on that structure.
I think, that was essentially my point, that if you have a structure and if you have gone through a basic structure, you will know, even if you are in the middle of that, if you have started that path, you will know that whether doing this is worth it or not. So I know there are a lot of people have created paths for themselves. If you search beginner's learning path, I can say that almost all of them is paths and which are basically trusted by everyone. So, and definitely when you have completed a basic path, you have some basic knowledge, you will eventually get to know what you want to do next. So when you have completed a basic path, you will know that if you want to go into computer vision, or if you want to go into natural language processing, or you want to go in time series, or you will eventually develop an interest, and you will keep on finding new things which can help you if you go through a basic structure at once.
My answer will be controversial, maybe. But core things for the two different paths in this profession. One is model-centric focused, about what we would call data scientists. They do a lot of analysis, they build models, they create a lot of prototypes and do a lot of research. And then the production side, which is either ML engineering or ML ops, whatever you want to call, whatever that job title will eventually be, the people that do that. I think there's commonality between both of those groups, that there is a foundation that needs to be there. And you need to know how to write code and not just copy paste stuff from the internet, put it into a notebook and hope that it's going to work well. You don't have to write advanced code for data science stuff typically, but you should understand the fundamentals, how to write human readable code. And it doesn't have to be the most performance stuff, but from the ML engineering side, there should be more of a focus on that. You should be pretty darn good with software and know that you need to continue to get good with that, and focus on optimizations and testability and the ability to write code that can be maintained and extended. But there should also be a common foundation in statistics on both sides. It's really tough to understand the concepts of how a model or an implementation would work, like the underlying library, if you don't have at least moderately advanced statistical knowledge. And if you don't have any of that knowledge, it's really hard to even determine if your solution is even going to work. And we've talked in the past, Michael, about A/B testing and how do we do attribution analysis. Like, hey, if deploying this model to production is run for a month, should we keep it in production? Yes or no? If an executive asks you that, if you don't know how to analyze that and provide the correct analysis of, hey, this is objectively what this is doing. It's causing our revenue to go up or our membership to go down or whatever it may be. You need to have a pretty deep understanding of statistics to do that stuff. And then the most important thing from both sides of that, I think, for a foundation is the soft skills. And two key soft skills. One is know how to talk to people and share ideas, listen to them, and test out things that they're suggesting. Be open to that, set your ego aside, and learn to work with people. It's super important in this profession. When you get, particularly the further along you get in it, and the more years you put behind you, you'll realize how important that is. And the successful people are the ones that collaborate and are just really nice to work with. And then the people who aren't nice to work with and want to be the lone wolf, just coming up with amazing models, they usually don't stay in this profession very long, no matter how good they are. And then the second aspect of the soft skills is, can you figure out problems in creative ways? Can you present it with a problem? Can you think outside the box and come up with clever solutions? That's really what this job is. It's not models. It's not, how good your code is. It's how well can you think, period. End of sentence. Can you get creative and talk with other people and come up with creative solutions?
Hey, folks, if you love this podcast and would like to support the show, or if you wish you could listen without the sponsorship messages, then you're in luck. We're setting up new premium podcast feeds where you can get all of the episodes released after Christmas 2020 without the ads. Signing up will help us pay for editing and production, and you can go sign up at devchat.tv/premium.
So let me see if I can recap this. So Ahmad sort of takes an academic approach and says leverage a pre-created path either through whatever resource you want to use. So blogs, podcasts, actual courses, or even university program. Ben takes the approach of be a god and be really, really smart. Ideally, you will have really strong programming experience, really strong statistical experience, but more importantly, you can distill problems into their component parts and sort of shift them around to your needs. I will take a third approach, which is the field is too big to try to learn it all. So I advocate for just doing what you like and trying to make an impact in that area. So an example is for my thesis, I was doing environmental science and did forecasts of coral reef health in the Caribbean Sea. So I would take a bunch of time series data that was very disparate, and then I would run into all these really crazy time series problems. And through that process, I got pretty comfortable with the state-of-the-art methods for doing time series analysis and found a bunch of holes that were just, the data were crap. So it just wasn't really possible. But this approach is really fun, and it helps you sort of take a bunch of creative angles because you actually care about the problem. So that would be my piece of advice. And then in terms of, that's sort of the high level process, but in terms of learning the first principles of your project, one thing that I found really helpful is spend 90 minutes on the internet Googling, and then do a couple more Googling sessions where you look up every single word or every single phrase that you don't know. So first pass, go through the first 10 Google results of how to do time series modeling, how to do this, how to do that. And then write down every word that you know. Next day, because this will exhaust you, next day, go and Google every single concept you don't know until you have every single concept outlined perfectly. And then from there, you sort of have the raw materials to understand a concept. And then as you start applying those materials, it'll start sort of assembling and chunking, and the hierarchical structure in your head will start being formed. So that is how I have done a lot of my learning, and it works really well for me, but it's also really painful. So it really depends upon your style.
I don't know if it's painful. I think that's kind of fun. Fun fact, when we're writing new implementations, like in my day job right now, when we're doing something that's like, hey, we need to interface with this open source project or this package, nobody on the team has any experience with it. Or maybe it's new and we just haven't seen it before. That's exactly how we do it. We read through their docs, go through the getting started guide, look at the examples. Yeah, that's cool. We'll give it a couple of minutes seeing, the structure of it. If anything stands out, like that's weird. And then go straight into the API docs and start reading through the main descriptions for the main access point for it. And anything that we don't know, we don't write it down. You just open up a new tab that's a search for that term or somewhere in that doc of like, what is this thing? Sometimes it's a link. If people are really nice in their API docs, it's a link to like a Wikipedia article or a white paper that explains what this thing is. Give that a read, a quick skim, read the abstract of it. Like, oh, okay, I know what this is. Or you get that other situation where like, I have no idea what they're talking about here. I've never heard of this before. Maybe I'm an idiot or just incredibly ignorant about this, or I thought I knew this, but this person is presenting it a different way. And then give some time to understand that so that when you do the implementation, you know what is important, why it's important. You can write your own docs on that other package that explain, hey, this is how this is used in our toolkit by using this other toolkit. And this is why we're using this way. So I think it's a great way to learn. It takes a little bit of effort, but you will learn it by following that procedure. But you brought up an interesting point there where you're only learning stuff that you need on that topic. When you were learning time series stuff, you probably went and checked out a couple of time series libraries, checked out the concepts behind it. And you're like, oh, that's what stationarity is. And like, oh, that's what, when I decompose the trend and I see these things, I can understand what the components are. But you probably didn't go out and learn everything there is to learn about time series. Good luck with that. That's an entire career worth of time. So you learned what you needed to learn in order to do the forecasting of coral reef health.
Exactly. Yeah, but you're 100% right. It's just scary looking into the abyss of a new like Wikipedia article and not recognizing every fourth word. But if you just have some stick-to-itiveness, it'll lead to understanding after some amount of time.
Yep, definitely.
Great. So we're coming up on time, but this has been really, really fun. Just to sort of recap what we've chatted about, we've talked about OCR and specifically what Ahmad has been doing at Red Buffer. He is working on developing simple and small OCR models that work on laptop-like devices for low latency applications. Some of the really effective methods that he used were preprocessing the data to grayscale and distributing different workloads across different threads. And so he's been doing some really, really cool stuff, and definitely suggest checking out his Katie Dungas post. I was reading it before this call. Lots of really, really practical tips for OCR optimization. So with that, Ben, do you have any closing thoughts?
No, I thought it was a good discussion, and hopefully people get something out of some of the little wisdom nuggets that we dropped there about how to learn, how to get started, and how to stay focused. And, how people do it at different stages of their career. So hopefully everybody enjoyed that. And I guess until next time.
Yeah. Let's just real quick before we close out. I know we want to, but, Ahmad, do you have any ways that people can reach out to you, whether it be through social media or LinkedIn or a blog post in case they want to get in contact?
Yeah, definitely. I'm mostly active on my LinkedIn account. I'll post the link to my account here, and you can definitely reach out to me on my LinkedIn.
Beautiful. All right. Well, until next time, it's been Michael Burke
and Ben Wilson.
And thank you, Ahmad, for joining us. Bye, everyone.
Take it easy.
Bye.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CacheFly.com to learn more.